Section 4.1 Scatter Diagrams and Correlation. The objectives for this lesson is to draw and interpret scatter diagrams, describe the properties of the linear correlation coefficient, compute and interpret the linear correlation coefficient, determine whether a linear relation exists between two variables, and explain the difference between correlation and causation. So far in chapters 1 through 3, we've been talking about one variable, such as your IQ score, your height. Now, in this chapter, we're going to talk about two variables. So, for example, does your height determine your IQ? So let's start with defining bivariate data. It is two variables are measured on an individual. So an example would be the cola consumed and bone density. So let's get into a scatter diagram and how it is created. But first, let's review what response variable is and explanatory variable. The response is the dependent variable. It depends on the explanatory. Again, the explanatory is the independent and it explains the response. So a scatter diagram is a graph that shows the relationship between the two quantitative variables. Each individual represents a point. Explanatory variable is plotted on the horizontal axis, and the response on the vertical. So if we go back up to the cola consumed and bone density, if we had the data for this could be on a scatter diagram because they're both quantitative. You could not have cola consumed and hair color because hair color is qualitative. It is a characteristic, and you cannot create a scatter diagram with a qualitative variable. So you will need these both to be quantitative in order to create a scatter diagram. Let's work on an example. A golf pro wants to investigate the relation between the club head speed of a golf club, measured in miles per hour, and the distance in yards the ball will travel. He realizes that other variables besides club head speed also determine the distance a ball will travel, such as club type, ball type, golfer, and weather conditions. To eliminate the variability due to these variables, the pro uses a single model of club and golf, one golfer, and a clear 70-degree day with no wind. The pro records the club head speed, measures the distance the ball travels, and collects the data below. Draw a scatter diagram of the data. So we first need to determine which one is the explanatory and which one is the response. So you can ask yourself, does the head speed explain the distance? Or are we asking, does the distance explain the club head speed? So if you read up above, they are looking for this one. This is not what we're looking for. So the club head explains, so this means this is the explanatory, and explains the response. So distance is your response. If you look up above, The explanatory is on the horizontal. So club head speed is on the horizontal. And then distance is on the vertical. Then we can label this. We can say distance versus club head speed. And then we can label the vertical and horizontal. So let's look at the vertical. We can see we're going from about 250s to about the high 270s. So we're going to put a break in here. And then I'm going to go start at 255. I'm going to go by 2.5s. So I'm going to skip a line and add 5. And that's the same thing. And then on the vertical, I'm going to do a break again because we're starting off at 99 and we're going to 105. So I'm going to go up by 0.5. So basically I'm skipping a line and adding 1. Just so it's a little bit more spread out and not all crunched together. And now we plot the points. So we have 100, then 257. So find 100 on the vertical, and then go up to 257. 102, 264. 103, 274. And so on. All right, you should get something like similar to this, and that is a scatter diagram. Sketch a scatter plot that shows a linear relation between an explanatory variable and a response. So if we plot some points like this, and then this would be another one. So this first one, there's 3 ways to say this. We could say it is positively associated. We could say positive slope. And then we can say as one variable increases, the other increases. This one is now negatively associated. Negative slope. As one variable increases, the other decreases. So as this increases, this y is decreasing. And as this increases, the other one increases as well. Next, let's sketch a scatter plot that shows a non-linear relation. So it has a relationship, but just not linear. So this is non-linear, but you can clearly see it does have a relationship. And here's another example. Again, it's not linear, but it does clearly have some kind of a relationship. Lastly, sketch a scatter plot that shows no relation. So this is just dots all over. You can see that there's no pattern being defined. So this would be no relation.